presents myself, Hanasha, Assistant Professor at LG Institutes of Engineering and Technology. So today we are going to discuss few more topics of system of linear equations and matrices. So let us begin with the first topic, that is system of non-homogeneous linear equations. So a system of m non-homogeneous linear equations in n variables x1, x2 up to xn is a set of m linear equations, each in n variables. A linear system of such type is represented by a11x1 plus a12x2 plus and so on a1nxn is equals to b1. And similarly, we can write m number of equations. So mth equation is am1x1 plus am2x2 plus and so on amnxn is equals to bm. So in all there are total m equations and n variables, right? So we will write this in matrix form as Ax is equals to b, where our A is equals to A11, A12, A1n and so on, AM1, AM2 and AMN, right? This is known as a coefficient matrix of order n cross n, and these are the coefficients of each equation, right? Now x is equals to x1, x2 up to xn, which is a vector of order n cross 1, and our b is equals to b1, b2 up to bn. These are all constants, right? And is a vector of order n cross 1. Okay. Next, solution of system of non-homogeneous linear equations using Gauss elimination method. So we will solve the system using Gauss elimination method. Okay. So for a system of m linear equations in n variables, there are in all three possibilities of solutions of the system, right? So the possibilities are: the system has unique solution, the system has infinite solution, and lastly the system has no solution. Okay. Next, now if the system of linear equation has one or more solutions, that is, if the system has unique or infinite solution, right, then the system is said to be consistent. Otherwise, it is inconsistent. That is, suppose if the system has no solution, then the system is known as inconsistent. Okay. Now, the matrix A is to B is equals to A11, A12, A1n and so on, AM1, AM2, AMN, and here we will write all the constants, that is B1, B2 up to Bn. Now this type of matrix is known as an augmented matrix of the system of linear equations. That is, here you have to write A and this side you have to write matrix B. Okay. Now, to solve a system of linear equation, elementary row transformations are used to reduce this matrix into either row echelon form or reduced row echelon form. So basically we will reduce this matrix A is to B into row echelon or reduced row echelon form using elementary row transformations, right? Now suppose if we are reducing the augmented matrix to row echelon form, which form? Row echelon form, then the method is known as Gauss elimination method. Okay. Now next, suppose we are solving the equations using Gauss elimination method, right? Then the method will go as follows. So the first step is we have to write the augmented matrix, that is A is to B. Okay. Now the next step is to obtain the row echelon form of the augmented matrix by using elementary row operations. So we have to reduce this into row echelon form, right? Now the next step is we have to write the corresponding linear system of equations from the row echelon form. That is, after forming the row echelon form, we have to write the linear system from that. And the last step is we have to solve the linear system obtained from the row echelon form using back substitution. Okay. So now let us solve examples based on this. So we have to solve the following system of linear equations using Gauss elimination method. And the equations are x plus y plus 2z is equals to 9, 2x plus 4y minus 3z is equals to 1, and the last equation is 3x plus 6y minus 5z is equals to 0. So let us start with the solution. So firstly, we will write the system in our matrix form. That is, we will write the coefficients of the equations first. So the first coefficients are 1, 1, 2. From next we will get 2, 4, minus 3, and from the last equation we will get 3, 6, minus 5. Now our variables are what? X, Y, Z, right? And lastly write the constants. They are 9, 1 and 0. Okay. Now this matrix notation is in the form of Ax is equals to B. So now we will form our augmented matrix of this system. So finally A is to B is written as, write this matrix A over here and write the matrix B over here. Now what we have to do, we have to reduce this augmented matrix into row echelon form, right? So here we have leading one, right? Okay. So we have to form 0 at these two positions. So which row operations we will use? R2 minus 2R1 and R3 minus 3R1. So using these two row operations we will get, first row will remain as it is, that is 1, 1, 2, 9, and the next rows will be 0, 2, minus 7, minus 17, and the last row is 0, 3, minus 11, minus 27. Now we have to form the leading one over here, right? So which row operations we will use? We will take out 2 common from R2, or we can say we will divide by 2. Okay, so on dividing you will get first and last row will remain as it is. So the second row will be 0, 1. On dividing you will get minus 7 upon 2 and minus 17 upon 2. Now you have formed leading one over here, right? So our next step is to form 0 at this place, right? So which row operations will be used? R3 minus 3R2. So on applying this row operation, you will get first two rows will remain as it is and last row will be equals to 0, 0, minus 1 upon 2, minus 3 upon 2. Now, in order to form the leading one over here, right, what we will do is we will multiply row 3 by minus 2. So on multiplying row 3 by minus 2, you will get first two rows as it is, multiply this by minus 2. So you will get 0, 0, 1 and last will be 3. So now you can see this is our desired row echelon form, right? Wherever there are leading ones below it, it is 0. Okay. So now we will construct a linear system from this row echelon form. So the linear system will be x plus y plus 2z is equals to 9. The next equation will be y minus 7 by 2z is equals to minus 17 by 2 and the last equation will be z is equals to 3. Now what we will do, we will put the value of z is equals to 3 in these two equations, right? So this procedure is known as back substitution. So firstly let me put the value of z is equal to 3 in our equation 2. Okay, so what we will get? Y minus 7 by 2 times 3 is equals to minus 17 upon 2. Right? So on solving this you will get y minus 21 upon 2 is equals to minus 17 upon 2. Now take this on this side. So you will finally get y as minus 17 upon 2 plus 21 upon 2. That will give you answer as 4 upon 2. Now this will get cancelled and finally your answer of y is 2. Now we will put the values of y and z in our equation 1, right? So let us put the values. So x plus 2 into 3 is equals to 9. So finally you will get x is equals to what? 1, right? So in general we have found out the values of our variables as x is equals to 1, y is equals to 2, z is equal to 3, which is our solution of the given linear system. You can also verify this answer by putting values of x, y, z in any of the equations given in the question. Okay. Now let us solve one more example. Here we have to solve the following system of linear equations using Gauss elimination method, right? So the equations are 3x plus y minus 3z is equals to 13, 2x minus 3y plus 7z is equals to 5, and the last equation is 2x plus 19y minus 47z is equals to 32. Okay, so let us start with the solution. So here the matrix form of the following system can be written as, write down the coefficients first. So the coefficients are 3, 1, minus 3, next are 2, minus 3, 7, and the last coefficients are 2, 19 and minus 47. Now the variables are x, y and z. And now write down the constants, and they are 13, 5 and 32. Okay, now we'll reduce this system into augmented matrix, right? So our augmented matrix is written as, write down your matrix A here and matrix B over here. Okay, now we'll reduce this augmented matrix into row echelon form, right? So firstly we need to form leading one over here. So which row equation we will use? We'll divide first row by 3. So you will divide and get the following matrix, that is second and third row will remain as it is and first row will be equals to 1, 1 by 3, minus 1 and 13 by 3. Now our next task is to form zeros at these two places, right? Using our leading one. So the operations will be as follows. They are R2 minus 2R1 and R3 minus 2R1. So applying these two row operations and keeping our first row as it is, we have to firstly multiply first row by minus 2 and add into row 2. So you will get 0, minus 11 by 3, 9 and minus 11 by 3. Similarly, again multiply by minus 2 and add in R3. So again you will get 0, 55 by 3, minus 45 and 70 by 3. Now our next step is to form leading one at this position. So which row operations we will use? We will multiply R2 by minus 3 upon 11 and keep row 1 and row 3 as it is. So you will get first and third row as it is, just there will be a change in row 2 and what you will get 0, 1, minus 27 upon 11 and 1. So you have formed leading one at this position. Now only last step is remaining, that is we have to form 0 at this place, right? So what we will do is we will multiply row 2 by minus 55 by 3 and add in our R3. So applying this row operation you will get first two rows as it is, just multiply R2 by minus 55 upon 3. So first will be 0, the second element will be again 0 because minus 55 by 3 plus 55 by 3 will be equals to 0. Again if you simplify this and add minus 45, again you will get answer 0 and lastly you will get answer as 5, right? So here you can see this is our desired row echelon form. Wherever there are leading ones you have below it 0. Okay, now we will form a linear system from our row echelon form, right? So the linear system of the last equation will be equals to 0x plus 0y plus 0z is equals to 5. So from this what we can say that 0 is equal to 5, which is not possible. So our system is inconsistent, right? And hence we have no solution. Okay. So in today's session, in all we have studied method known as Gauss elimination method, right? So this method is used to solve a system of non-homogeneous linear equations, right, of order m cross n, right? So firstly, what we will do is, first step is we will form an augmented matrix A is to B, right? Where A are the coefficients of the variables and B are constant, right? In the next step, we will reduce this into our row echelon form, right? Now, in the third step, again from the row echelon form, we will form a linear system of equations, right? And solve this in the last step using what? Back substitution, right? And in all, we have three types of solution, namely unique solution, infinite solution, and lastly no solution. Okay. Suppose if we get unique or infinite solution, then the system is known as consistent system. Okay. And suppose if we get no solution, then the system is known as inconsistent. Okay. So I hope you have understood throughout the session. Thank you for watching.